you. Okay, everybody look, row 1. We're on Pre-Algebra Builder 26. We did row 1 and row 3. So if you're doing the recording, stop it and do that and then turn it back on to check. Okay, so what is the top row? 2C. Good. Good. Now distributive. You got to multiply both of those. That's the biggest problem. And then this would be what?
12b plus 8.
Good job. Okay, the third row, we've got 1/2 x minus 2. So 1/2 times 0 minus 2 is?
2.
1/2 times 1 minus 2? Okay, so what happened? As the x went up 1, what happened to these numbers? It increased by 0.5 or a half. Right? If you go from -2 to -1.5, you're going up to 0. We're on our way to 0, people. On our way to 0. Since this went up 1, guys, I knew that it was going to go up a half every time. Because a half is what? The rate of change, the slope. 1/2, guys, we just did this yesterday. I'm not asking you to put off something from 3 months ago. 1/2 is the what? Two people know that. What is 1/2? Or is this proportional?
No.
Why not?
The
y-intercept is what? -2. So we're going to start at -2. Guys, we all should know that. We should all know now that this is not proportional because that's a -2, the y-intercept. So we're starting at -2. Now the slope is what? 1/2. Rise over run. So I'm going to run 2 up 1. Run 2 up 1. Should my line be going up?
Yes.
Why?
Because it's a positive slope.
Which is what? What's the slope? 1/2, which is positive. So you know it's got to be going up. Guys, these are the kind of things we cannot miss. This is too easy. We've worked on this too long and hard, and y'all know it. Okay? Good. Put this in warm-ups. Look at the 9.2, please. Look at the 9.2, please. I think with you guys on D65, what did I do with you on D65? Did I do any of those with you? I did 7. Did I do 1 and 7? Okay, good. So in just a minute, you're going to finish D65, D66. Are there any questions on those? God bless you. No questions on it? Okay. So I need, oh wait, before we do this, let me do this. What is this? Oh, I can't see it on the recording. I'll have to make it smaller. Okay. This is a, well, I still can't see it, can they? Okay, this is a cube, guys. This is a cube. How many faces does it have? 6 faces. So let's come up with our own formula to get the surface area of the cube. Okay, wait a minute. How many faces are there? You said 6. And each face is a what? It's a square. And they're all the same, correct? All the faces are the same. So let's come up with a formula. How do you get the area of one square? Base times height, or length times width, or side times side, or side square. Good. So wouldn't you just take the side and square it? Oh, that's easy on our calculator. Boom, we got one little button to push. So we could just do side times side squared, and then multiply it by 6. So to get the surface area, let me make this bigger now. You would multiply 6 times side squared. Okay, what if you were building one of these cubes for the playground out there, a big one for the kids to climb on? And you're going to paint it. And you're going to paint it. Would you paint the bottom that's going to go on the ground?
No.
I wouldn't waste your time. So you would paint how many sides?
5.
So the surface area would be a 5 there. Like, what if you made this open on the top so they could climb in it? And somebody said so they could get stuck. Well, you're making it big, okay? I don't think they're gonna get stuck. Huh? Or we could put a door. Okay, so let's don't do what? Yeah, so let's don't do this right here. Let's make this open so they can climb in. So, how many sides would that be?
4.
And when it be 4, because you're not gonna paint the bottom, it'll be 4. But if I'm doing the lateral, guys, I'm doing all 4 of these sides, or not. So I'm just going to have 4 faces. True?
True.
So here's what the state of Texas wants you to know. Wants you to be able to do. Take what you know to find out what you don't know. That's what they want you to be able to do, is to reason through. Oh, I'm getting the surface area of the cube, but I'm not going to paint the bottom or the top. So that's 4 sides I'm doing. They want you to be able to reason through this and get it right. And think for yourself. Because, guys, when you get to a job, most of the jobs, you have to do a lot of thinking on your own. You have to figure out stuff. Nobody's there telling you how to do it. Okay, so that's a cue. Now, look at this right here. Read the directions, Trent, for right here.
Okay. Any solid number 1 through 3 and then find the lateral.
Everybody circle lateral and say lateral.
Lateral.
On your formula chart, your reference chart that you're supposed to have out. Freeze. On your reference chart, find surface area and find lateral. You're going to use the lateral formula. The lateral, okay? And you're going to name it. Hey, I put a word bank on the board. You're not going to use all those words. Okay? That reminds me, Coach Brewster one time gave a test and he put word bank at the bottom. He said word bank and he put the words. Guess what somebody put in the blank? Word bank. Mm-hmm. Mm-hmm. They did. That's a true story. No. Mm-mm. They thought that was one of the words they could use. Now in science, would you think word bank is something you learn? No. Maybe atom or, but word bank, no. Okay, look on number 1. Look on number 1. I know that this is 8. Everybody draw around the triangle, because that's the base. Big hint. That's the base. And everybody draw a little right angle in there. I forgot to do that. Draw a little right angle. We need the length of these 2 sides, don't we, to get the perimeter. And if they had a hash mark like you do on a football field, they're called hash marks, 1, 1, 1, then you would know all these are 8. But guess what? They're not. This is a right triangle. And I know that's 3. And that side is, what is this side? Well, I know, but what is it? No. Good. That's going to be 4. So if that's 3 and that's 4, what's that? Oh, good job, guys. Why is it 5? The 3, 4, 5 rule. Now, somebody this morning said they didn't understand the 3, 4, 5 rule. I'm going to explain it one more time. They really should have asked before now when we do a Pythagorean theorem, but they didn't. So I want to just clear this up. Guys, this could be 3 and that could be 4, and that could be 7, but that's not going to be a right angle. If I want this to be a perfectly 90-degree angle, right angle, if that's 3 and that's 4, then the length from there to there has to be 5. It can't be any other number. If it's any other number, that's not going to be a right angle right there because it's not going to, the angles aren't going to match up perfectly for that to be 5. Okay? So you've got 3, 4, that has to be 5. And remember when we put it in the, this is the first one we did. When we put it in the a squared plus b squared is c squared, it worked. 9 plus 16, 25. 25 equals 25. Check. If you put another number in there, if you put 6 or 8 or 10, it's not going to equal. So it can't be a right triangle. So you know that has to be 5. Well, you've got the same right triangle over there, so that's 5. Okay, look. Oh, excuse me. So look at number 2. Look at number 2. We've got another right triangle right there. This is 6. That's 6. What's that side? 8. So what do we know that side's going to be?
7.
Now, wait a minute. Isn't side C the longest side? Side C the longest side? Huh? So it can't be 8. It can't be 7. Where did y'all get 7 from?
I got 6, 7, 8.
Well, but the longest side has to be C. Nope. Why is it 10? Guys, 3, 4, 5. Remember, if you take a right triangle and I dilate it, and it's 3, 4, 5, and let's say I multiply all of them by 2, it's going to stay the same shape, so it's going to still be a right triangle, but now it's going to be 6, 8, 10. Remember? 5 times 2 is 10. One year, a student went home and asked his uncle about, because he welded or something, or was a carpenter, I can't remember exactly. But he said, do you know the 3, 4, 5 rule? And he said, well, I call it 6, 8, 10. He called it the 6, 8, 10. I thought all welders and all called it 3, 4, 5, but he said he called it the 6, 8, 10. He used 6, 8, 10 more than he did 3, 4, 5. But guys, if you take 3, 4, 5, which you know is a right triangle, and multiply by any number, all 3 sides, you're going to get another right triangle. Well, if you multiply by 2, 6, 8, 10, that's also going to be a right triangle because the shape doesn't change. Okay, so 6, 8, 10. Got it? Okay. Now, on the back, 3, you're going to name it and do the lateral. You're going to do the lateral. Okay? And you're going to use okay, look, draw this in there. Can y'all draw the little dotted? This is going to be the base. Use this for the base. Because you can use any of them. Well, let's use that for the base. Okay, and on number 5, I forgot to put the radius in there. The radius is 5. Okay? Now, you're going to finish D65, 66, and then you're going to work on this. This is the one I want turned in. Don't turn in D65, 66. Just put it in practice. And then start working on this. I need you to move or get a blinder, and you may listen to music, as long as it's not a problem.